Hello, grade 10 students. Welcome to week number 7 of the second quarter, where we will be discussing optical instruments. In this lesson, our most essential learning competency is to identify ways in which the properties of mirrors and lenses determine their use in optical instruments. If you remember last week, what we have discussed is all about reflection in mirrors. Pinag-aralan natin yung iba't ibang klase ng mirrors. We have plane mirrors and curved mirrors. This time, we will be using that knowledge for us to understand how each optical device works. Specifically, we will be discussing these 4 optical devices. First, the camera. Second, microscope. Third, the telescope. And fourth, binoculars. Are you ready? If yes, let's start. Before we proceed with the mechanism of each type of optical device, let's have a brief review of important physics concepts. What are these physics concepts? First, we have reflection. Reflection was discussed last week. Reflection is defined as the bouncing back of light rays as they hit a smooth surface. Just like in this ray diagram, you can see the incident ray, the reflected ray, the normal line, the angle of incidence, and the angle of reflection. All of these governed by what we call the laws of reflection. Tandaan po natin, ang ating key term sa reflection ay bounce or bouncing. We also have another physics concept that we will be discussing today, and that is refraction. Now, what is refraction? Refraction is the bending of light when it travels from one medium to another. Tandaan po natin yung pagkakaiba ng dalawang term. Pag sinabi nating reflection, we refer to bouncing. When we say refraction, we refer to bending. And this only happens when light travels in different media. Pag sinabi nating in different media, yan yung iba-ibang klase ng matter. So halimbawa, light is traveling from air to water. O kaya from water to air. Or from glass to air and vice versa. So whenever the medium changes, light bends because of differences in optical densities. So, pwedeng si light ay bumilis ang kanyang paggalaw, pwedeng si light ay bumagal ang kanyang paggalaw. It depends on the type of media or on the type of medium where it moves. And that is called refraction. So, why are we emphasizing these physics concepts? Because just like what we have discussed last week, when we are talking about mirrors, we talk about reflection. Now, when we talk about lenses, lenses have refraction. Sa madaling sabi, ma'am, ano ba yung mirrors? Ano ba yung lenses? Paano ba namin madaling malalaman yung pagkakaiba ng dalawa? Sa Tagalog, pag sinabi nating mirror, ito yung salamin na ginagamit natin para makita natin yung sarili natin. Marami tayo niyan sa ating bahay. Yung lens naman, ito yung kadalasan nakikita ninyo na suot-suot ng mga taong malalabo ang mata. Pero, hindi lang yon limited doon. Marami pang ibang function yung lenses. That's only one of the applications of lenses. So, let's discuss lenses further. We have 2 types of lenses. We have first the converging or convex lens. Yung term na converging, hindi yan first time na narinig ninyo. Kasi when we say converging, we mean that light rays are going into one point. Sila ay nagko-converge, sila ay nag-i-intersect, just like in this diagram. As light rays pass through the lens, the light rays converge at one point which we call the focus. So, ano ba yung mga application ng convex lenses? So, yung convex lens, ito yung mas maraming application kaysa dun sa isa pang type ng lens na makikita nyo maya-maya. So, one example of a convex lens is the human eye, yung mata natin. Aside from that, optical devices have convex lenses in them, and also, yung mga eyeglasses na ginagamit sa pag-correct ng tinatawag natin na farsightedness or hyperopia, convex lens ang ginagamit doon. So, when we say farsightedness, ito yung mga tao na nalalabuan sa mga bagay na malapit sa kanila. Tapos, kapag malayo, yun yung malinaw. So, farsighted ang tawag doon. The medical term or the scientific term is hyperopia. Again, we use a convex lens to correct that type of eye defect. On the other hand, we also have diverging or concave lenses. This is the opposite of converging or convex lens because this time the light rays diverge. Ibig sabihin naghihiwalay. That is the complete opposite of converge or converging. And what are the applications of concave or diverging lenses? Some optical devices have them as well. And this time, concave lenses are used to correct nearsightedness or myopia. So, yung nearsightedness, ito yung mas common sa mga nakasalamin. Ang malabo sa kanila ay yung mga bagay na malalayo. Ang malinaw ay yung bagay na malalapit. So, to correct that, you need an eyeglass that has a concave lens in it. So much for the different types of lenses. We will now go to the 4 optical devices that we have enumerated a while ago, starting with the camera. Okay? So, yung camera ay isang optical device na hindi na naman bago siguro sa ating lahat kasi karamihan sa atin ay nakakita na at nakahawak na or nakagamit na ng camera. We are not referring here to the cameras of our phones, but we are referring to the actual camera that looks like this or this. Okay? So, these are the 2 types of cameras. The first one on your left is a DSLR camera. Ito yung usual na gamit ng mga photographer. And DSLR stands for Digital Single Lens Reflex Camera. The one on the right is called a mirrorless camera. Ito yung mas ginagamit ng mga Gen Z ngayon. Mas magaan siya at mas mura compared sa DSLR camera. But both are digital. When you say digital, we no longer use films. Okay? Whatever you take using these cameras are saved directly to your SD card or to your memory card. Okay? Now, what is the basic difference between these two? Sabi nga natin, doon sa term na isa, mirrorless camera. So, therefore, a DSLR camera would have a mirror in it, whereas a mirrorless camera, okay, ito yung kaya nga siya mirrorless, wala siyang mirror, and that makes the camera more compact, and ito rin yung nagbibigay ng less weight kay mirrorless camera. But then, still, most professional photographers would prefer DSLR camera. Let's discuss this further. What is the structure of a camera? So, what type of lens is inside it para mas maintindihan natin kung paano siya nakakapag-produce ng image. This is a simple diagram of a camera, top view. So we have here on this side, we have here a convex lens. So this convex lens converges the light rays coming from the object being photographed and produces a real inverted image. Now, the first question that may come to your mind is, ma'am, bakit inverted? Hindi naman baligtad po yung nakikita namin sa aming camera if you are able to use a camera in the past. We will be discussing that in a short while. But then, what's important for now is for you to know that the lens here is a convex lens or a converging lens. Now, if the object would be in different places or different positions with respect to the lens. So, ang ginagawa ng photographer dyan or the one using the camera, he or she adjusts the lens para clear yung magiging image na lalabas doon sa camera. So, ano ba yung mga important parts ng camera na kailangan nating tandaan? Okay, so for example, we are taking a picture of a girl playing soccer. So of course, we have the lens. The lens is again a convex lens and it is a piece of curved glass that will focus light, allowing clear images to be transmitted onto the film or the sensor. Again, we are no longer using films right now. We are using the sensors already. And the convex lenses would produce real inverted images. So we also have the aperture, okay? So, itong mga term na to ay familiar siguro sa mga laging gumagamit ng cameras. It is a hole wherein the size can be changed to allow light to pass out of the lens and into the camera. Of course, the aperture would change depending on the amount of light needed for the image. Kasi may mga image na masyadong maliwanag yung light sa labas, may mga image na masyado namang madilim, so kailangan mag-adjust si camera doon. We also have the shutter. It is a doorway that will allow light to pass through and out of the aperture onto your sensor or your film. So makikita natin sa image natin, we also have the CCD. CCD stands for Charge Coupled Device. It enables your camera to transform the visual information, this is your visual information, converting that visual information into image that will be saved as a picture or video into your SD card. Makikita po natin dito again, the image form is real but inverted. Now, another feature of a DSLR is the mirror. A DSLR has mirrors to allow the photographer to see the image that your camera sees. So, kung si girl, katulad kanina, nakatayo, ang mapo-form na image niyan ay nakabaligtad. Pero kung gusto nating makita, kapag sinilip natin sa camera na siya ay nakatayo, there is a need for a mirror and some prisms inside the camera for us to see the actual orientation of the object being the subject of the camera. Okay, siguro ang next question ninyo, ma'am, sabi niyo po yung mirrorless camera, wala siyang mirror. Paano niya nababaligtad yung image na nakikita ninyo? So, yung mirrorless camera, marami na yung advanced technology sa loob, meron na yung electronic viewfinder na dinidisplay na niya, piniflip na niya automatically yung image para yun yung makikita natin dun sa screen ng camera agad without the use of mirrors. Okay? There, that's the camera. Next, we will be discussing the microscope. So, most of you have already used a microscope when you were in grade 7. Somehow, you have an idea on what a microscope would look like. But then, the microscope that you were using on the laboratory is a compound microscope. For a simple microscope, that would be the magnifying glass. Ito very common siguro to sa mga bahay natin. Ginagamit yan usually ng mga older people whenever they are reading very small letters or very small text from dictionaries or whatsoever. A magnifying glass looks like this, and then this is the ray diagram of a magnifying glass. Since you are placing the object in between the lens and the focal point, then what you will be producing is an enlarged image that is virtual. Again, a magnifying lens is a simple microscope. As for the compound microscope, it looks like this, and in terms of the parts, We have two main types of lens here. We have the eyepiece lens and we have the objective lens. Remember, when we are talking about an eyepiece lens, we are referring to a lens that is closest to our eyes. Kaya nga siya eyepiece. Kapag sinabi naman natin na objective lens, ito naman yung lens na closest to our specimen. So in the case of a microscope, we have different types of lenses. We have the higher power objective and the low power objective. Binabago natin yan depende dun sa pangangailangan natin. And we place the specimen here on our stage. And we are able to see enlarged images with the help of light that is reflected by this mirror. Without this light, you can't see the image. Very important yung light na yan. Again, a microscope is an optical instrument or an optical device composed of two convex lenses of short focal length. Convex lens pa rin. Why are we specifying short focal length? Kasi you are placing the specimen very close to your objective lens. So that requires short focal length for you to be able to produce a larger image. Kasi syempre, for a microscope, the goal is to enlarge the specimen. So the larger the image, the better. This is a simple ray diagram of a microscope. As you can see here, you have a convex lens on your objective and you also have another convex lens on your eyepiece. So what happens is that you have a very small object here and this object may light na pupunta dyan galing dun sa mirror. The light rays are refracted and forms a larger image here, which in turn becomes the object for the eyepiece lens. Kaya magkakaroon pa ng mas malaking image. So, para mas makita natin, halimbawa kayo ay nag-e-examine ng specimen ng langgam, maliit yan. This is your object. Again, the light rays coming from the bottom of the microscope, pictured a while ago, would cause the light rays to converge. Okay, at this point, this is a real enlarged image produced by this lens, and this image would then be the object of the eyepiece lens, okay, which in turn will produce this enlarged image na mas malaki kaysa dito. This is a virtual image but a larger image than the object. So, ganun po ang goal ni microscope. So, minamagnify pa niya yung image na nakukuha natin sa specimen using the two convex lenses. Now, the third type of optical instrument that we will be discussing today is the telescope. The telescope also has an eyepiece lens and an objective lens. And we have two types of telescopes. First is the reflecting telescope and the second is a refracting telescope. So, pag titingnan po natin yung kanilang itsura, hindi natin makikita yung kanilang difference. But then, by looking at the terms, we have reflecting and refracting. We can already identify what devices are placed inside of them, whether it's a mirror or a lens. So, of course, for the reflecting telescope, we have mirrors inside. And for a refracting telescope, we have a lens. So, hindi lang isa, more than one. Let's start with a reflecting telescope. So, again, a reflecting telescope uses mirrors instead of lenses to focus light. And a concave mirror is used to gather light. That would be your primary mirror. And another mirror or your secondary mirror would be used to direct the light coming from the primary mirror towards the eyepiece. So, ganito yung kanyang itsura. Ayan. Makikita natin, we have light rays coming from infinity kasi our object would be stars or any celestial bodies. Napakalayo niyan sa atin. Compared to the focal length of the mirror, napakalayo ng distance na yan. So, these light rays would come in parallel, almost parallel to your concave mirror. Here, that would be your primary mirror. And then, the light rays would bounce towards your secondary mirror, which is a flat or a plane mirror, and that would bounce your light rays towards your eyepiece. Ibig sabihin, in a reflecting telescope, we use two types of mirror, a concave mirror and a flat or a plane mirror. On the other hand, for a refracting telescope, again, lenses will be used. A refracting telescope, yung mga modern refracting telescope, gumagamit sila ng two convex lenses, but the old ones would have one convex and one concave. Katulad nito. Okay, so this is a ray diagram of the old telescope invented by Galileo Galilei. So the objective lens would be convex, but the eyepiece would be concave. Yung mga modern telescopes naman, we have both convex lenses. So, mas malaki yung image na na-form kapag dalawang convex lenses ang ginamit. Ito yung mga modern types of refracting telescope. Ang goal naman ni telescope ay mapalapit yung mga bagay na malalayo. At syempre, pag malapit yung mga bagay na malalayo na yon, lalaki rin yung kanilang image. Finally, we have binoculars. So, binoculars are similar to telescopes. Yun nga lang, hindi ganun kalaki or kalakas yung kanilang magnification power kasi hindi nila kayang makakuha ng image na galing sa space. Usually, binoculars are used for just distant objects found on Earth. Okay? So, halimbawa, gusto mo makita ng image na nasa kabilang bundok. Yan, pwede mong medyo mapalapit yung image na yon with the help of a binocular. A binocular is an optical instrument consisting of two similar telescopes used for providing a magnified view of distant objects. So, parang dalawang telescope yan kasi tig-isang tube kada mata natin. So, ano bang itsura ng structure ng binocular? Still, we have an eyepiece lens and an objective lens. But for the binocular, to be able to rotate the image, kasi inverted yung image na maho-form dyan, it needs prisms inside. It needs at least 2 prisms for one tube. Bakit dalawa? Kasi one prism would rotate the image by 90 degrees. So you need to rotate the image 180 degrees. So you need 2 prisms inside for one tube. And for both tubes, you will be needing 4 prisms. Just like in this diagram. Okay, so that's all for today. I hope that you have learned something about the 4 different types of optical instruments. So thank you for listening and see you again next week. Bye!